This video is the first video in the complex number set of videos, and in this video we're going to look at the different types of number systems that we have in mathematics. To begin with, the first type of number system we're going to look at is natural numbers, or a natural number. Natural numbers, also known as counting numbers, are positive integers used for counting. So they're just our counting numbers, which are 1, 2, 3, 4, 5 and 6. The most important thing, it does not include 0. The symbol is an n, and examples, I have a few there, but they're right the way up to infinity with all of the whole positive numbers. Now, to represent these on a number line, you only mark the whole numbers and include an arrow if needed, but you do not fill in or shade the spaces between the numbers, and this is best explained with an example. In example 1.1, it says plot x is greater than or equal to 3 on the number line where x is an element of n. So to begin with here, I'm going to draw my number line. I'm going to place 0 in the center, and then I'm going to put a few numbers either side. So 1, 2, 3, 4, 5, and then I include an arrow, and then maybe -1, -2, -3, -4, and -5, and I'll include my arrow as well. So in this one it says x is greater than or equal to 3. So because it's greater than or equal to, it could be 3. So I'm going to colour in 3. It's greater than, so it could be 4 as well, it could be 5, and then it could be 6 or 7 or 8 or 9 or 10, so I colour in the arrow as well, indicating that it goes on to infinity. So now I've labelled and plotted x is greater than or equal to 3 on the number line when x is an element of n. The most important thing is you don't colour in between, say, 3 and 4 or 4 and 5. The next one, it says plot x is greater than -1 on the number line where x is an element of n. Again, I'm going to start with 0 in the center and place a few numbers either side of the 0. I'm going to go up to 5 again, and I'll go down to -5. On this particular one, we have x is greater than -1. Now, it's x is an element of n, which is the natural numbers. Because it's the natural numbers, the first natural number that we have is 1. So because it's x is greater than -1, it can't be 0 because 0 isn't a natural number. So the first natural number that it could be is 1. It's greater than -1, so it could be 2 or 3 or 4 or 5, or indeed any number up to infinity. So I include my arrow here as well. Example 1.3 says plot x is less than or equal to 7 on the number line where x is an element of the natural numbers again. To begin, I'm going to draw my number line. In this case, we have 7, so I'm going to need to go up to at least 7. So I have 1, 2, 3, 4, 5, 6, 7, 8. And then -1, -2, -3, -4. Here it's x is less than or equal to 7. Because it's or equal to, it could be 7, and it's less than, so it could be 6, it could be 5, it could be 4, it could be 3, it could be 2, it could be 1. Now, it can't be 0 because 0 isn't a natural number. It can't be -1 or 2 or 3 or 4. So it's only the numbers 1, 2, 3, 4, 5, 6 or 7. Again, do not colour in between them because it doesn't include, say, 2.5 or 2.6 or 2.5 or 2 3/4. Example 1.4 says plot x is less than 2 on the number line where x is an element of n. Again, I'm going to draw my number line. I'm going to plot 0 at the center, and then 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. Now that I've got my number line drawn, I need to plot x is less than 2. Because it's less than 2, it doesn't include 2, so it includes 1. And it actually can't include 0 or any of the negative numbers because it's x is an element of n, which is the natural numbers. So the only possible number that this could be is 1. It doesn't include like 1.5, 1 3/4 because a natural number is a positive whole number. The second type of number system you need to know about is integers. Integers are whole numbers that include 0 as well as their positive and negative counterparts. The symbol for integers is Z, and examples include all of the natural numbers, 0 and negative numbers, and most importantly, it's just the negative whole numbers. When plotting integers on a number line, mark only the whole numbers, include the arrow and avoid filling in or shading the spaces between the numbers. It's very similar to how we would have plotted natural numbers. You plot integers in the same way. In example 1.5, it says plot x is greater than or equal to 2 on the number line where x is an element of z. So again, I draw my number line, I pop 0 in the center, and then I write my numbers either side. Here I'm going up to 6, and I'll go down to -4. We are plotting x is greater than or equal to. So because it's greater than or equal to, I can include the 2. It's greater than, so it could be 3 or 4 or 5 or 6. And then it includes all of the other numbers above that right the way to infinity. We don't colour in because it just is whole numbers when we're dealing with integers. Example 1.6 asks us to plot x is greater than -4 on the number line where x is an element of z. To begin, I draw my number line, I pop 0 in the center, and then I write my numbers up along the number line. On this one, we're plotting x is greater than -4. So first of all, I'm going to colour in -3 to begin with, because it's not greater than or equals to. So it's all of the numbers bigger than -4. It's the whole numbers as well, so it doesn't include anything between the numbers. So we're just colouring in the actual numbers themselves. And we include the arrow because it could be any number right the way up to infinity after -4. In example 1.7, it says plot x is less than or equal to -2 on the number line, where x is an element of an integer. Again, I'm going to plot my number line. When you're plotting your number line, it's really important that you put the dashes in as well. So just to make sure that you're doing that every single time you pop the dashes in, just to show exactly where each of the numbers is. On this particular one, we're plotting x is less than or equal to -2. So it could be -2, and it's less than that as well. So -3, -4, and then we colour in the arrow 2, as it could be any number from -2 right the way to -infinity. But it's only the negative whole numbers, so you wouldn't include any of the, or shade in any of the parts between -2 and -3, as it couldn't be -2.5. Example 1.8 says plot x is less than 6 on the number line where x is an element of z. Again, here I'm going to start by drawing my number line, popping 0 in the center. As it is less than 6, we have to go right the way up to 6. And it is less than 6. So it doesn't actually include 6 because it's not less than or equal to. So the first number that it could be is 5 or 4 or 3 or 2 or 1. It could be 0, as 0 is an integer. -1, -2, -3, -4, -5. And it could be any negative whole number after -5 too. So we colour in the arrow. The next type of number we need to know is real numbers. Now, real numbers include every number that can be located on the number line. This covers fractions, decimals, irrational numbers, and integers. The symbol will be or, and literally any number you can think of. So -1, 0, -2.3, 0.3, pi, a quarter, epsilon, any of those numbers would all be real numbers. So literally any number is a real number. When plotting real numbers, draw a continuous line that connects the whole number and fills in the spaces between them. Extend the line with an arrow if needed to indicate that the line continues indefinitely. And again, it's best to explain this by going through a few examples. Example 1.9 says plot x is greater than or equal to -1 on the number line where x is an element of the real numbers. So to begin here, I'm going to draw my number line. going to pop 0 in the center, and then I'm going to pop my numbers either side. Here we're looking for x is greater than or equal to -1. Now we're looking for greater than or equal to, so it does include -1, and it's all of the numbers above -1 or greater than -1. So we colour in the line to the right of -1, and we also colour in the arrow, because it could be, say for example, 8 or 9 or 10, but it could be 10.5 or 11 3/4, any number at all greater than -1. Example 1.10 says plot x is greater than 6 on the number line where x is an element of OR. Again, I'm going to start by just drawing my number line. As this is x is greater than 6, I am going to have to go up to numbers greater than 6 on my number line. So on the left hand side of the 0, I'm going to go up to 8. I might even go up to 9. As it is x greater than 6, it doesn't include 6. So when it doesn't include a whole number or a number on it, we put a circle around it and don't colour it in. So it doesn't include that 6, but it could include 6.00000001. So every number past that whole number 6 would be included. So we colour in the arrow from 6 right the way up the rest of the way, including the arrow, because it could be 6.5 or 6 2/3 or 6.3 or 6.003 or any number that's just past 6. Of course, it could include like 6.9 or 7.5 or 8 3/4. All of those are included too, so that's why we colour in the line. Example 1.11 says plot x is less than or equal 3 on the number line where x is an element of OR. Start by drawing my number line, placing 0 in the center. Now we're looking at x is less than or equal to 3. So when we go to 3 on the number line, it is less than or equal to 3. So it does include the 3 and all the numbers smaller than 3. So -4, -3, -2, -1, 0, 1 and 2 are all included. And of course, all the numbers between those on the number line too. So we shade in the number line, and then we also shade in the arrow at the end. So we've now plotted x is less than or equal to 3 on the number line. Example 1.12 then, it says plot x is less than -4 on the number line where x is an element of OR. Again, I'm going to draw my number line. We have 0. Okay, so it's less than -4. Now, it doesn't include -4. So when it doesn't include it, we put an open circle around it so that we show people that it doesn't actually include -4. But it does include all the numbers that are less than that. So it could be -4.001 or -4.5. So we colour in the line right the way up to -4. And we also include the arrow, as it could be any number smaller than -6 as well. The final two types of numbers that you need to know are rational numbers and irrational numbers. Now, first of all, you don't need to know how to plot rational and irrational numbers. You just need to know what they are and be able to identify one. So type 4 is rational numbers, and all they are is numbers that can be expressed as a fraction, where a and b are integers and where b is not 0. The symbol for rational numbers is Q, and the most important thing about rational numbers is they include all positive and negative whole numbers, as all positive and negative whole numbers can be written as their number over 1, which is a fraction. Otherwise, we have things like 1/6, 2/9, and any other fraction that you can think of. Now, numbers such as pi wouldn't be a fraction, even though sometimes pi can be rounded to a fraction as 22/7, but that wouldn't be what pi is, because pi is an irrational number. It can't be written as a fraction. Another example of a number that wouldn't be a rational number would be square root 2, as it cannot be written as a fraction. And the most important thing is, if you are unsure whether a number is rational or not, is think about whether it can be written as a fraction. And when it's written as a fraction, it has to be a fraction of integers, so i.e. the numerator and denominator have to be positive or negative whole numbers. And the b cannot be 0, as when we have a fraction that has a number on the top and 0 on the bottom, that is undefined. Finally, we have irrational numbers. Irrational numbers and rational numbers are basically the opposite of each other. Irrational numbers are numbers that cannot be expressed as a fraction of two integers. Their decimal forms neither terminate nor repeat a pattern. What that means is, if you are unsure whether a number is a rational or irrational number, you could type it into your calculator and press equals, put it into a decimal form, and if it terminates, as in if it only has a few decimal numbers, or if it's repeating, so for example, if it's like 12.111111 repeating just the number 1, well then it could be written as a fraction. But if it's not repeating, so if it's random numbers that we would have in the decimal place, then it's going to be an irrational number. Some of the common irrational numbers we'd have would be pi, square root 2, epsilon, square root 3. And again, check by typing them into your calculator and you'll see that they have non-repeating or terminating fractions, so they continue indefinitely. So there are the 5 types of number systems that you need to know in Leaving Cert Ordinary Level Maths, and it's really important that you're able to distinguish between the 5 different types and also place numbers in. So like, for example, if you're given a number as -3, be able to say, right, is that a natural number? Is it an integer? Is it a rational? Is it an irrational number? So check which ones they can actually go into as well. That then brings us to the end of this video, which is all about the different types of number systems that you meet at Leaving Cert Ordinary Level Maths.